us find out what happens when a plane wavefront is incident on a convex lens. Now ABC represents a section of a plane wavefront. Now you know what is the phenomena taking place in a lens. It is refraction. So the rays of light after refraction, since it is a converging lens, has to converge. So we are not bothered about the rays, we want the wavefront. So how will you find out the shape of the refracted wavefront? Now if you consider the points A and C, it travels a larger distance in air and it just gets refracted at the edge. So even after refraction, it can travel a longer distance. If you consider the points A and C, after refraction, it can travel a longer distance. Now, if you consider the point B, it travels partially through the air and it takes a longer time while traveling through the medium, denser medium. So when it travels inside the medium, it takes a longer time, which means that after refraction, it cannot travel a longer distance. So let us consider that after refraction, it travels over here. Now if you consider the point A and C, comparatively, it travels a longer distance. The envelope of all these points will give rise to a spherical wavefront. So you can mark it as A dash, B dash, C dash. The time taken for A to reach A dash must be the same as the time taken for B to reach B dash, is the same as the time taken for C to reach C dash. After refraction, it travels a longer distance. Here, after refraction, it travels a shorter distance. Here, after refraction, it travels a longer distance in order to compensate for the time. That is why when a plane wavefront is incident on a lens, the shape of the refracted wavefront will be spherical. Now, again, I have a question for you. Suppose if you keep the light source or if you keep the object at the focus of the convex lens, what will be the shape of the refracted wavefront? Once again, when the object is placed at the focus of the convex lens, what can be the shape of the refracted wavefront? Now let us see what happens when a plane wavefront is incident on a concave mirror. What can be the shape? Now this is a concave mirror and a plane wavefront is incident. These are the rays. Okay. A plane wavefront, ABC represents a section of a plane wavefront which is incident on a concave mirror. So my question is, what will be the shape of the reflected wavefront? In a mirror, the phenomena taking place is reflection. Now, similarly, if you consider the 3 points A, B and C, if you compare A and C, it travels a long distance. Over here it is traveling completely through air over here, and the time the point A and C, it almost travels the same distance before it gets reflected. But if you see the point B, compared to A and C, it has to travel a longer distance before it gets reflected. So compared to A and C, B travels a longer distance before it is getting reflected. So after reflection, it can travel only a shorter distance. A and C, it travels a shorter distance. So after reflection, this is reflection. So after reflection, it can travel a longer distance. Here this is going normally, so it is a retracing. Now here the reflection is shown over here. So it is traveling a shorter distance compared to B. So after reflection, it can travel a longer distance. Similarly, here also, the envelope of all these 3 points will be a spherical wavefront. Let me mark this as A dash, B dash, C dash. Once again, the time taken for A to reach A dash is the same as the time taken for B to reach B dash, is the same as the time taken for C to reach C dash. The envelope of all these points is nothing but a spherical wavefront. All these are the 1 mark questions that are normally asked. What happens when a plane wavefront is incident on a mirror? The shape is a spherical wavefront. What happens when a plane wavefront is incident on a prism? Again you get a plane wavefront. What happens when a plane wavefront is incident on a lens? It is a spherical wavefront. So be thorough with all these points.